Hi, welcome to EC&M Tech Talks. This is a series of how-to videos where we cover everything from basic electrical theory to installation work that we perform out in the field, maintenance type work that we perform, and codes and standards that apply to our everyday work practices. So anyway, welcome. This is brought to you by Electrical Construction and Maintenance Magazine. That's EC&M Magazine. And so if you haven't already, you need to go to ecmweb.com. That's ecmweb.com. And when you get there, click on a menu on the upper left-hand corner. And the very first drop-down item says premium content. You want to go ahead and sign up for premium content if you haven't already. Why? Well, let's see. One, it's free. And two, you'll get all types of valuable information to help you in the trade. Everything from these tech talk videos to related topics, articles, other media types, videos, and so on and so forth. So be sure and do that. If you haven't already, go to ecmweb.com and sign up for premium content. I'm Randy Barnett. I'll be the facilitator for today. And today we're going to be talking about the PPE category method, the table method, the tables, 70E, electrical safety is what we're talking about. We know that according to the NEC 110.16 says if I'm going to go up and operate a piece of equipment like this disconnect switch, that there needs to be a label on there to warn me of any arc flash hazard that might be present. Now, the NEC says the label has to be there. And then there's an informational note that tells you to go to NFPA 70E if you need to know what type of information has to be on the label. So we could go to the NFPA Article 130 and we could find out specifically what type of information needs to be on the label. But unfortunately, the label is not always there. And there could be many reasons for that. Maybe we haven't yet completed an incident energy analysis required by 130.5 in the NFPA 70E standard. Now, the NFPA 70E standard, the standard for electrical safety in the workplace. And this is the most recent edition. This is the 2021 edition. So this is what we're going to be using for our reference today. So in addition to maybe the arc flash analysis not yet being completed, there could be good reasons for that. Maybe this is a disconnect for a pump skid or an HVAC unit or a rooftop unit or as part of an air handling unit or something like that. And it just got installed. And engineering has not yet had time to go through and do the incident energy analysis and determine how many calories per square centimeter would be available to us at a certain distance from that disconnect when the door is open, when we're exposed to the hazard then. Or maybe the label is there, but we've had some changes recently in our electrical distribution system. Every 5 years, your arc flash analysis has to be reviewed. The labels don't have to be replaced and they need to. But let's say we just recently changed out and put a new transformer upstream that's feeding this disconnect. That new transformer has a different impedance value. And so that's going to change the amount of available fault current that's into the disconnect. That means that the current label that would be on the disconnect would be invalid and it needs to be redone. But engineering hasn't had a chance to do it yet. So no matter the reason, if there's not a label present or the information on the label we suspect may not be correct, we can use tables in the NFPA 70E standard to determine what arc flash PPE we would be required to wear to prevent our bodies from burn injuries, which is a good deal, right? So what are those tables and how do we use them? There's always been a lot of discussion around those tables. Well, one is, can we use the tables? Are they really too conservative? Are they safe at all? You should never use the tables. All of those types of discussions have evolved over the years. The bottom line is the tables that we're going to be talking about today that are referenced as the PPE category method do appear in the requirements for NFPA 70E. So therefore, yes, we can absolutely use these tables, the information that's in them, to help us to determine what PPE we need to be safe from the burn injury. That's just electrical common sense, as I would call it, isn't it? I need to go do the job. I can't stop doing work because I don't have enough information to do the job if the information is available to me. So why not grab your NFPA 70E, figure out what PPE category of clothing you should wear, and you can go ahead and safely get the job done. So there generally, we talk about there are three tables that we're going to use in this PPE category method, or what we often just call the table method. So I'll probably use both today. Before we even get into the first table, though, we're going to cheat a little bit, because the first table is going to ask us to determine whether or not this disconnect is suitable for normal operation. So what does that mean by normal operation? So we're going to go to 110.4D. 110.4D defines normal operating condition for us, and it gives us 6 items that we must be aware of. So let's review those, then we can jump into the table. The first item, the equipment is to be properly installed. Well, if the equipment was installed per the original installation codes and standards, it met those requirements and was inspected at that time. If we've done any additional work, such as we've just recently added this disconnect in that system, then it needs to be inspected and verified that it's been installed per the National Electrical Code requirements and any other applicable code requirements, local jurisdictional requirements, and so forth that would apply. The second item says that the equipment has to be properly maintained. Well, we need some records then. So we're going to go out and we're going to say, throw this disconnect down and open up this door in order to check the fuses on the inside, or re-energize the disconnect and take some clamp on ammeter readings or whatever it is. So in order to open that door, we need to have on the appropriate PPE again. So in order to determine if it's been properly maintained, we've got to have maintenance records to go back and look and see when was the last time this disconnect was maintained and when is it scheduled for its next maintenance in. The third item, it says that the equipment is used in accordance with instructions, including in the listing and labeling in accordance with manufacturer's instructions. So bottom line is, are we using this disconnect in accordance with manufacturer's instructions? Now, the fourth item is, it says that the equipment doors are closed and secured. Well, we got one door in a disconnect. It's closed right now and it's latched down here at the bottom. It says all equipment covers are in place and secured. Pretty simple. On the disconnect, all we really have is the door. If we had something like a switchboard or switch gear, maybe even control panels, we could walk around and make sure all the covers are in place and properly secured. And then the last item is, it says there is no evidence of impending failure. So once again, that's a lot based on our experience, isn't it? I mean, we need to be able to look at this equipment and go, well, I don't see any burn marks on the outside. I don't smell any burnt insulation when I walk up to it. There's no water dripping on top of it. All of those items that would indicate that maybe something is wrong with it. So the first thing I have to determine is, do I meet those 6 requirements? If I do, then I say the equipment is suitable for normal operation. Randy, what happens if it's not suitable for normal operation? What if I don't meet all of those 6 items? Can I still go ahead and work on this side of this disconnect today? And the answer is right in 7E. It mentions in a few places the need for taking additional precautions. So if I don't meet one of those 6 requirements, I, the electrical professional, have to determine what is safe to work on. What additional precautions do I need? Maybe I need additional PPE. Maybe I need to lock out and tag out an upstream breaker. Whatever it is, I need to make sure that it's safe to work on them. Now, let's go to the tables and find out what they have to say about the PPE category method. The first table we're going to go to is table 130.5C. 130.5C. And I'm going to read some things to it out of you to give you an idea of what's going on. But anyway, it's titled Estimate of the Likelihood of Occurrence of an Arc Flash Incident for AC and DC System. After I review my requirements for normal operation, the next thing I'd like to know is there really a likelihood that I'm going to have an arc flash incident? And what do we mean by likelihood anyway? Likelihood of occurrence, the column says. Well, what that is, that's in the opinion of the electrical professionals, that if this equipment is suitable for normal operation, and I'm following all of my safe work practices, wearing any appropriate PPE, I would wear and so forth, that if I operate this equipment, there would be little likelihood that an arc flash would occur. But it could. In fact, they tell us in 70E, electrical equipment sitting by itself like this disconnect is not likely to have an arc flash at all. It's most likely to occur when I operate the disconnect, when I interact with the equipment, in other words. So in this first table, 130.5C, we need to go down and find out what task is it that we're going to perform. I'll read a couple of examples to you. For example, it says, reading a panel meter while operating a meter switch. What equipment condition is it in? Once again, it doesn't matter whether it's a normal operating condition or not. They're telling us that there is not a likelihood of occurrence of an arc flash occurring. That's probably true, reading a panel meter, right? Things like examination of insulated cable without manipulating the cable, just to look at a cable and a cable tray. There's no likelihood that I'm going to have an arc flash occur. Performing infrared thermography. Now, I may well have to wear my appropriate PPE to do that infrared thermography, but is there a likelihood of occurrence of an arc flash occurring just because I'm using a camera and taking a picture? No, probably the biggest danger is just opening the cabinet door if I need to do that in that case. Now, we get on down to some other items where we may find that 70E considers it to be, yes, there is a likelihood of an arc flash occurrence. Now, when I say there's a likelihood, don't get confused with that. It doesn't mean I say, watch out, man, it's about to happen. You better be careful. It's going to happen to you. No, it just means that it's more likely to occur. I always look at it this way. In the unlikely event that an arc flash should occur, I want to make sure my body's protected. That's the bottom line. That's what we're talking about here. So let's see if we can find something about operating this disconnect switch. It says for AC systems, work on energized electrical conductors and circuit parts, including electrical testing. Oh, so if I'm going to go in while the disconnect is energized and take some electrical readings, they say, yes, there is a likelihood of occurrence. What about just operating the switch, though? Let's see what we can find. Removal or installation of circuit breakers or switches. No, we're not removing anything here. Applications of temporary protective grounding. No, we're not doing anything like that. Oh, how about this one? Operation of a circuit breaker, switch, contactor, or starter. This is a disconnect switch. I want to pull the handle down. So that's operation of the switch. So that item, that task would apply then. So here's what it says. If the equipment is in normal operating condition, it tells me that there's no likelihood of occurrence, meaning that I could come up here according to the PPE category method. And as I'm dressed right now, my normal everyday work clothing, I happen to have on a ARC rated shirt rated for 8.7 calories per square centimeter. And I could go ahead and pull this handle down if I've determined this is suitable for normal operation. Now, in reality, I would probably at least wear some rubber gloves with leather protectors or leather gloves in the unlikely event that I may need some protection. Follow your company procedures and policies. Some organizations require full PPE to be worn based on the category method or the label, whichever you're using, in order just to operate the switch. But by the category method, if I'm suitable for normal operation, it says the likelihood of occurrence of an arc flash occurring is no. Now, let's say if it's not suitable for normal operation. For instance, I've decided that this piece of equipment is not being maintained. Or let's say that this is newly installed equipment and this is the first time we're going to operate this disconnect. Then yes, they tell us that in that case, there would be a likelihood of occurrence. So the next thing I need to know then is, well, what PPE do I have to wear? What's the category level? How many calories per square centimeter? So that's going to take me to the next table, which is table 130.7C15A, arc flash PPE categories for alternating current systems, or a corresponding table 130.7C15B for DC systems. We're talking about AC, so we're going to use the AC table then. Now, this particular table has three columns to it. The first column gives me the type of equipment it is: panel board, switches, circuit breakers, motor control centers, medium voltage equipment, whatever it is. The second column over tells me the PPE category. I don't know much about the PPE category yet, but this will tell me the PPE category. And then the last column tells me the arc flash boundary. That's going to be where the incident energy drops to 1.2 calories per centimeter square, which would be the onset of a second-degree burn then. So I need to find my piece of equipment, and it's not a panel board, it's not a motor control center, and it's not medium voltage equipment. So there's really only one grouping left, and it says other 600 volt class 277 through 600 volt nominal equipment. And so this would be 480 volts equipment. This disconnect is rated for 480 volts. So it would fall in this line for other equipment. And it tells me in that line that it's PPE Category 2, PPE Category 2, and that my arc flash boundary is 5 feet. Okay, so I'll have to set up a barricade at either the furthest of the limited approach boundary or the arc flash boundary, right? In this case, it would be the arc flash boundary of 5 feet, because you know the limited approach boundary is based on voltage, and at 480 volts, it's 42 inches. So we'll set up a physical barricade out at 5 feet then, at least that far back from the exposed energized conductors on the inside before we operate the switch, because we said maybe it's not suitable for normal operation, or it's a new disconnect and we haven't yet operated the switch. And so we want to make sure it's safe to use. So that Category 2 and that 5-foot arc flash boundary, though, are based on two parameters. Well, what's that? Think about it. What's going to determine how severe an arc flash is in the unlikely event, okay, that I do have one at this disconnect? Well, let's see. It's going to be how much current can flow into the disconnect and for how long a period is it going to flow. So those parameters are provided to me. I can have a maximum of 65,000 amps of fault current flowing to this disconnect. That's a lot for this little disconnect. And the maximum clearing time for the upstream overcurrent protector device can be 30 thousandths of a second, which is 2 cycles. And then my minimum working distance, the distance that I keep my head and chest back when I operate this equipment, in this case would be, it says 18 inches. So how do we determine then, and this is always seems to be the problem with using this table method. So how do we determine what the available fault current is and what's the clearing time on the upstream overcurrent protector device? Well, a couple of things. One, it's easy to determine available fault current generally. We go to the upstream transformer, we get some data off of the transformer. We take a look at its kVA rating, its voltage, and its internal impedance, how much opposition it presents to AC current as that current tries to flow through it during a fault condition, because that's going to limit the current flow. So we can use the formula up on your screen to determine the amount of available fault current. Now, there are some notes and informational notes at the bottom of this table that might be able to help you to determine the clearing time of the upstream overcurrent protective device. Informational note. It says 1.5 cycles, so that would be less than our required 2-cycle maximum. Fault clearing time is typical for molded case circuit breakers rated less than 1,000 volts with an instantaneous integral trip. Well, it's going to have an instantaneous trip in order to protect us from that arc flash. So that is one source that can help you. If you're not sure on when that upstream breaker or fuse is going to operate for you and clear the fault in the event of an arc flash incident, then what you need to do is you need to look at the manufacturer of that piece of equipment and look at the ratings on it and go to its time current characteristic curve, which is available from all manufacturers and can be used to determine the trip time of that overcurrent protective device. Then, if you're not familiar with those, get familiar with them. Okay? There's plenty of software out there available. Manufacturers have plenty of information. They're really not difficult to read. You just look at the amount of fault current that's available on the graph, and you go straight up to where it intersects with a line telling you how much time it'll take that overcurrent device to operate. Really, it's not a good excuse to say, well, we don't know the clearing times, or we don't know, there's no way we can tell the available fault current. That's not true. You can figure that out. And as a professional, that's something we need to be able to do out in the field. Now, once we determine the PPE category, that's great, but tell me, what PPE do I have to wear? That's also in a table, and it is table 130.7C15C, okay? Personal protective equipment, PPE. And so there are 4 different categories, 1, 2, 3, 4. Each category tells you specifically what items you have to wear in order to protect your body from an arc flash incident. Category 1 tells me that the minimum arc rating of my clothing would have to be 4 calories per centimeter square. In addition to that, it's going to list things like long sleeve shirt and pants or coveralls, arc rated, of course, an arc rated face shield or suit hood. So yeah, we'd have to go to our arc rated face shield or the suit hood if we're wearing that. What else does it tell us? It says arc rated jacket, parka, high visibility apparel, rainwear, or hard hat liner as needed. Protective equipment, you have to wear a hard hat, safety glasses, you have to wear some hearing protection, ear canal inserts in, and heavy duty leather gloves, arc rated gloves, or rubber insulating gloves with leather protectors. So quite often we'll either wear the leather gloves or we'll wear rubber gloves with leather protectors. Though these are not arc rated, they will provide you, according to the table, and they will provide you adequate arc flash protection in the event of an incident. It goes on from there, and I won't read all of these to you. You can look them up in the table, but the minimum arc rating for PPE Category 2 clothing is what I have on. Minimum calories of 8 calories per centimeter square. PPE Category 3 must have a minimum arc rating of 25 calories per centimeter square. And PPE Category 4, you must have a minimum rating on your clothing of 40 calories per centimeter square. So look at the table and determine specifically what PPE you need to do the job. So let's go back and recap here. The first thing that we want to do then is that we want to determine whether or not the equipment is suitable for normal operation. Then we want to see if there's even a likelihood, given those conditions, that there's going to be an arc flash for the particular task that we're going to be performing. If there is, or we feel that there is, for whatever reason, we go to another table, and it's going to tell us for that specific equipment what PPE category and what the arc flash boundary will be when we perform that particular task. We have to meet 2 parameters. We have to make sure that we're below the available fault current, and we are within the specifications for fault clearing time. You can do those on your own. Then the final table we will go to will tell us for a particular category what specific clothing we must wear. So that's it. Spend some time in your NFPA 70E. Get familiar with those tables. Remember, lifelong learning is something that we should do as electrical professionals. And so that's all the time we have for this Tech Talk video today. The main thing is I want you to go out of here and get some practice using those tables. Remember that this series of Tech Talks is brought to you by EC&M Magazine, ecmweb.com. And they're part of the portfolio of Endeavor Business Publications. So I'm Randy Barnett. Make sure you get out there and you work safely. Use your PPE category method if you need to. Get into 70E, get some practice using it beforehand, and be safe.